high affinity, okay? High affinity, it means that I cannot release it very easily. Where we have R in a location that are full of oxygen, exactly, for example, what happened inside the lung, okay? So, we have a deoxyform. Deoxyform means that T, low affinity. And oxyform, you have a R form, high affinity. And about I explained cooperative effect, hand-to-hand interaction. About the allosteric effect, you should know that R4, T4 and R form can be affected by many situations. For example, pressure of oxygen, temperature, presence of carbon monoxide, presence of carbon dioxide. In many situations, the R form and T form can convert to each other. Please pay attention, whenever you have a sigmoidal pair, you have these actually allosteric effect. I mean that in a sigmoidal curve of hemoglobin, you have a hem-to-hem interaction. But in a myoglobin, because only one polypeptide chain is present, we don't have any cooperative effect, okay? And I mentioned that the net effect of affinity, it means that the last oxygen, for example, here we can see 300 times easier than the first one. Explain it. Bohr effect. Maybe I'll ask you about the definition of the Bohr effect. I want to find the correct definition of Bohr effect. Bohr effect is the definition of the effect of the proton or pH and pressure of carbon dioxide on the affinity of the hemoglobin to the oxygen. When we say, please pay attention, do not make a mistake, okay? Sometimes in your question, I give you the proton concentration, and sometimes I give you pH, okay? They have an indirect relation. Low pH, high proton concentration, okay? Please do not make a mistake. So, according to the Bohr effect, decrease in pH and increase in a pressure of CO2. Where we have this point? In the tissues, in the active tissues. For example, we use a glucose as a source of energy. Then you use a glucose as a result, for example, sometimes you make an acidic environment. And in a Krebs cycle, you make a CO2 as a metabolism, end product of metabolism. Our hemoglobin connects to these ions and change the structure to the T form. Do you understand? How proton has a positive ion, okay? And CO2 can change to the T form. It's very clear. I mentioned that T structure is actually interaction between negative charge and positive charge, okay? So whenever you add any positive or negative charge, you can facilitate the T form. So what is the charge of proton? Positive. So it can facilitate the formation of the ionic bond or salt bridge. And about the CO2, please pay attention, CO2 can add to the hemoglobin as a COO minus, okay? Because it provides a more negative charge, it can facilitate the T form. And about the last point of this slide, as I mentioned, at least one of your questions would be from this slide. What is important? You should know that in which situation the curve shifts to the right. Okay? In Farsi we say rast, T form. Rast. You are familiar with the direction in Farsi? Rast, chap. Rast, T form. Okay? In English, we can say, for example, right, left. In Arab, we can say. Do you remember? Yasar, okay? In Farsi, I cannot say right, left also because the last letter also in left and right is T, we cannot say T. But in Farsi, rast, T, Arab, Yasar, R. Okay? So, you should be familiar with all these aspects. T form is clear. This is the oxyform. The oxyform is a low affinity. In which situation? Low pH, high 2 and 3 diphosphoryl high carbon dioxide, high temperature. You have an increase in P50. You have a shift to the right. But in contrast, for example, carbon monoxide, hemoglobin F, in contrast to this situation, high pH, low pressure of the carbon dioxide and low temperature, you have a R stabilization. So, please focus on this slide by details, okay? By details. And about the hemoglobin, if you remember, I asked you to memorize the beta thalassemia and alpha thalassemia. We have a major and minor. In a major, 2 genes of beta globin are defective. In a minor, 1 gene is defective. And also, this box is very important. Maybe I asked you about whenever our body cannot synthesize beta genes, what are the other kind that replace hemoglobin F and hemoglobin A2, for example, in beta thalassemia? In alpha, you have another type of accumulation of amino acid, another accumulation of amino acid, hemoglobin, like hemoglobin BART, and, for example, hemoglobin H, because can I make it alpha 2 beta 2? No, because this is the alpha thalassemia. You cannot synthesize alpha. So instead of alpha, we make it beta. For example, beta 4 is a hemoglobin H. Gamma 4, known as a hemoglobin BART. And about the vitamin, actually, only 5 minutes, okay? Only information, these are not important. I want to focus on the main important, okay? This slide is very important and you should be familiar whenever. What does it mean? Co-substrate, what does it mean? Okay? Whenever you have a loose connection, co-substrate. Prosthetic, strong. Okay? And maybe I ask you about which of the enzymes are active form. You should know that holoenzyme is active form. Holo means that a coenzyme that require one component. This component now sometimes is metal, sometimes is vitamin. Okay? So this is a holoenzyme is active. About the classification, you should know that which vitamin are water soluble, which vitamin are lipid soluble. About the general name, the title. Actually, to be honest, in this slide, just the title. The generic name or the scientific name of vitamin B1. This is a thiamine. About the name of the coenzyme. This is a thiamine pyrophosphate. About the enzyme that are important as a coenzyme, the gray box. Transketolase, dehydrogenase, and also alpha-ketoglutarate dehydrogenase. 3-phosphate considered as a one molecule can function as a control of our nervous system. To evaluate the level of the vitamin B1, transketolase is important. If I ask you, very important, and also, what is the sample question at first? I want to actually overall review the vitamins. Maybe I give you about which item correctly show the active form or coenzyme form of each vitamin. For example, vitamin B1 is thiamine pyrophosphate. Please pay attention to the abbreviation also, okay? TPP. For example, for vitamin B2, FAD, okay? For vitamin B3, NADP, okay? For folic acid, tetrahydrofolic. Both of them are the same, depending on the oxidation and reduction situation, okay? NAD and NADP is important. And about the name of disease, for example, maybe I ask you, as a result of deficiency of vitamin B1, which disease can produce beriberi? We have a different type, and also Wernicke-Korsakoff. The symptoms is very important. Maybe I give you a case. For example, I give you. You have one case who cannot control the movement of the muscle and she cannot remember the events that take place in the last night. Okay? Memory loss. Okay? Please pay attention to the symptoms. No, it's clear that we cannot, in Farsi, we say that نمیدونم دیشب شام چی خوردم. I can't remember the last night was actually as a dinner. It's clear, okay? This is not, it's as a result of the alcohol consumption and use actually. About the riboflavin, I mentioned that the structure is not important. FAD, FMN are the active form. This slide is not important. This slide is very important. Maybe I ask you, chylosins, okay? Glossitis and dermatitis are deficiency symptoms of which vitamin? Vitamin B2. For evaluation of vitamin B2, which enzyme can be measured? Glutathione reductase. Vitamin B3, I mentioned that NAD and NADP also is coenzyme form of these vitamins. About the function, this slide is not important, but this part was important. Not also it can consider as a coenzyme, but also can participate in the adding of ADP, ribose to molecules. This slide is not important because it explains some reaction that take place in a metabolism. This is a general rule. Just know that niacin can participate in an oxidoreductive reaction. 3D symptoms are for dermatitis, diarrhea, dementia, as a result of deficiency of which vitamin? We have a 4D. 4D is, the last D is death, whenever the deficiency is very severe. In a heart valve disease, in a pellagra, we have a deficiency of niacin. Maybe I ask you, for treatment of the hyperlipidemia, which vitamin can use? B3. About this slide, I mentioned that only these two lines, the title, and you should know that the vitamin B5 considered as a component of coenzyme A and acyl carrier proteins, okay? What about the deficiency? Nowadays, we cannot say, for example, we have any specific disease that can relate to the deficiency of these vitamins, and this is just for more information. Maybe, I don't know, maybe in your basic science exam, the designer asks you, for example, I don't know, isoalloxazine ring present in which vitamin? For example, riboflavin. I don't know. For example, beta-alanine present in which vitamin? So I put it intentionally because maybe you have to review for your basic science exam. But for your level, and inshallah, about my question, I never asked about the structure. About this slide, only PLP. Know that pyridoxal. Al means aldehyde. Pyridoxal, please pay attention. Pyridoxine, pyridoxal. What phosphorylated form is a coenzyme form of vitamin B6. This slide, please eat this slide, okay? Chew this slide completely. بجویدش. This slide is very important because vitamin B6 is very, very coenzyme in many enzymatic reactions like a transamination, decarboxylation, deamination, and the first reaction of the heme synthesis or condensation. So these are considered as a main enzymatic reaction that require B6 as a coenzyme. About the deficiencies, sometimes, just remember this one, okay? The erythrocyte transaminase considered as an enzyme that when you want to evaluate the level of vitamin B6. Maybe I ask you, which vitamin can be effective in the treatment of PMS syndrome? PMS, okay? Premenstrual syndrome, or in a diabetes, because it can facilitate the action of the insulin, so it can be useful in the treatment of the diabetes. In a biotin, what is the function of biotin? Transfer of carboxyl group, okay? So, no matter what is the first part name of enzyme, acetyl-CoA carboxylase, pyruvate carboxylase. Propionic way, carboxylase, okay? All the time, whenever we have a carboxylase, you require biotin. But we have one exception about carboxylation. Do you remember gamma carboxylation? Vitamin K, okay? About the deficiencies, is because they are not very common. About the folic acid, the active form, please pay attention, this is a tetrahydrofolic acid. It can transfer 1 carbon units. I know you are tired, but know that I'm more tired than you. After this class, also I have it to another class, okay? Ya Allah. And again, please review this slide because the interaction between, I cannot actually review by details. Just know that we have interaction between the function of the vitamin B9, folic acid, and vitamin B12, okay? The name of these drugs is very important, okay? Methotrexate as anti-cancer, trimethoprim as antibacterial, pyrimethamine as an anti-malaria. Drug can inhibit the dihydrofolate reductase and inhibit the division of the cancer cells, bacteria, and parasites. In this slide, just remember that if you remember, we have a different type of anemia. Okay, pernicious anemia, megaloblastic anemia, hemolytic anemia. One by one. Megaloblastic anemia, please pay attention, vitamin B9 and B12. Pernicious anemia, vitamin B12. Hemolytic anemia, vitamin E, okay? Because vitamin E protects the membrane of the RBCs, so whenever we cannot protect the membrane, RBC are lyses, so hemolytic anemia, okay? And it can protect the fetus about the occurrence of the spina bifida. Vitamin B12. Maybe I'll ask you about the name of the R or the type of the group. I mean, in cobalamin. If I ask you in a coenzyme 4 of the vitamin B12, R for R, adenosine, and sometimes methyl. But in a supplement of the vitamin B12, they are cyanide and hydroxyl. So this few lines is very important. About the source, I never ask you, but if I ask you, for example, some vitamins can produce by the normal flora of the body. I mean, for example, some bacteria that normally exist in the intestine. So this is a vitamin B12, one of them. And about the just name of the enzyme and the type of the vitamin B12 that can act as a coenzyme. So for methionine synthase, methylcobalamin is important. For methylmalonyl CoA mutase, the oxyadenosine is important. This reaction takes place inside the cytosol. This reaction takes place in a mitochondria. And about the digestion, just know that we require one important factor, and this is the intrinsic factor. Our stomach secretes an intrinsic factor. It can facilitate the absorption of vitamin B12. And exceptionally, this is a water-soluble vitamin, but we have some carrier and we have a storage, okay? As I mentioned, the pernicious anemia as a result of different situation and also megaloblastic anemia and some neurodegenerative disease can result as a vitamin B12 deficiency. The last vitamin, if I ask you which vitamin in our body is deficient, this is a gluconolactone oxidase is deficient in the human body, so human body cannot produce this vitamin. So we require the function one by one is important, okay? Maybe I ask you about the function. Maybe I ask you about it can decrease the absorption of iron. Is it correct? No. It can enhance. It can participate in the collagen reaction, in the dopamine, synthesis of carnitine, blood clots, and repair of scars. And scurvy, you're familiar. About the fat soluble, you should be familiar with the general characteristic. The RDA is not important, just this is if you want to compare different supplements from different companies. You can compare, is it enough to take, for example, this supplement or not. About the vitamin A, we have a 3-4, okay? What is important? We have a different role and function. Retinol is for reproductive system. Retinol is for visual cycle. Retinoic acid can act as a transcription factor for the growth and differentiation, okay? The review. This is not important, just for more information, this slide. And in a visual cycle, in a rhodopsin as a one-piece visual pigment, whenever on exposure on the light, these pigments can break down and send the signal to our brain, and we can see in the presence of the light. And we talk about this acidic form, growth, development, and differentiation, and about the biological function. They are important for the immune system, reproductive, healthy skin, and this is the vitamin, as I mentioned, this is vitamin required for the visual cycle. So it's clear that many kind of blindness can be related to the deficiency of vitamin A, and in a very severe situation of deficiency, it can cause a complete dryness of the eye and xerophthalmia. And toxicity, about the toxicity, these are the symptoms of the toxicity. It means that because they are not water soluble, but it means that if you take in excess, they accumulate and make a toxicity, especially for the liver. For example, it can cause a liver damage, it can cause, for example, skin damage and central nervous system damage. And about the vitamin D, we have some precursor under the skin, okay? If I ask you about the name of the precursor that located under the skin, this is a 7-dehydrocholesterol. On exposure to the UV light and a specific temperature, it can convert to the vitamin D. But is it active or not? No, it is not active. Question. This slide is very important in that, at first, we should be familiar with the type of active vitamin D. What is it? 1 and 25 vitamin D. Whenever you observe it, 24, it means that this is inactive. So, 1 vitamin D, 1 hydroxyvitamin D, 1 and 24 vitamin D, 24 and 25 vitamin D, 1 and 25 vitamin D, which of them is active? The last one, okay? But if I ask you, for example, 1 and 24 and 25, it seems that maybe at the first glance it sees that because of the presence at the position 1 and 25 is active. No. Because of the presence of 24 position, it became inactive. So, question, which organ, please pay attention, so most of the time I give you some sample question about the organs that are related to the vitamin D. If I ask you the name of the organs that can participate in activation, please pay attention, or which organs are important for the activation of the vitamin D, or liver and kidney. But if I ask you, which organs consider as a target of vitamin D? Bone, intestine, and kidney. And we have a rickets, osteomalacia, and osteoporosis as a result of the vitamin D. And sometimes vitamin D considered as a protective drug. For example, also in a coronavirus, we have many articles that demonstrate that vitamin D has a protective effect against coronavirus. And about the vitamin D, as I mentioned, the main important role of vitamin D at first acts as an antioxidant. Second point, it can protect the LDL. Are you familiar with LDL protein? So it can control and inhibit the atherosclerosis, okay? And also, it can protect the RBC membrane. So as a result of deficiency of vitamin E, we have a hemolytic anemia. Hemolytic amines is metalysis of the RBCs. And about the last vitamin is originated from German word coagulation. It's very clear that it's very important in the blood clotting process. We have a free form. This free form is very, very, very important. The name, okay? At first, K1 is a phyloquinone, K2 menaquinone, K3 menadione. Another important, if I ask you, the most biologically active form is K2. The normal dietary source is K1. The abnormally, vitamin K is a lipid soluble. But if I ask you, the water soluble form of vitamin K is K3 or menadione. So please pay attention. I focus on this slide, okay? The name of K1. Inshallah, in your exam, you can recall me. And K3, okay? And about some drugs can interfere with the action of the vitamin K. So, for example, warfarin considered as an anti-clotting drug because I mentioned that whenever you see carboxylation, biotin is important. But about gamma carboxylation, why we say gamma? Because, for example, this is carbon alpha, beta, gamma. You add another carboxyl at the position gamma, for example here, so it's now as a gamma carboxylation. Why we should add a carboxyl here? Because we should provide some field or background, negative background, to facilitate the binding of these positive charge, calcium, okay? So, for any molecule, like a protropin, like osteocalcin and nephrocalcin, because they require calcium, it's better to add one negative charge to facilitate the bond between this positive and this negative charge. As you can see here, warfarin can inactive the actually reduced form of the vitamin K. And about the deficiency, in which case we have a deficiency of vitamin K, whenever you take vitamin for a long time, you take antibiotics. Do you know why? Do you remember why? Whenever you take a prolonged antibiotic, you have a prolonged antibiotic consumption, they destroy the bacteria of the intestine. Okay? Normally, no one take a vitamin K as a supplement. Okay? We know that. For example, maybe sometimes some of you take a vitamin C, vitamin E, vitamin D as a supplement. But have you ever heard someone take a vitamin K? Why? Because inside the body, the intestinal bacteria can produce vitamin K. But in, for example, newborn babies, because they have a low fat store, they have a low vitamin K, immediately after delivery, we have to inject it K3 because it is a water soluble. This is the most available form of vitamin K for the newborn baby. And for evaluation, we have a BT, bleeding time. I mentioned that after make one, for example, pour on ear, you set a chronometer and you set the time, and after cleaning this bleeding, whenever the bleeding stops, you can calculate the bleeding time. And this is a review. Many thanks.